Next, very important question for 10 marks. They'll ask derive expression for, is very important. They'll ask either series resonance circuit or parallel resonance circuit. You have to derive expression for cutoff frequency. We already derived expression for resonance frequency, which is FR is equal to 1 over 2 pi root LC. This we derived for series RLC circuit. Now this is actually expression for cutoff frequencies. Cutoff frequency means F1 and F2. We have to find out what is the expression for F1, what is the expression for F2, and bandwidth also we can find out the difference between F2 and F1. So consider RLC circuit, series RLC circuit connected to the voltage source with variable frequency F here, and this is the frequency response, current versus frequency. X-axis is frequency and y-axis is current. And we know that current is minimum in the beginning. That when for a lower frequency current is minimum, for very high frequencies also current is minimum, and current reaches maximum at FR. So at resonance frequency current is maximum, and why current is maximum means for series circuit impedance is given by R plus J XL difference XC. At resonance frequency XL is equal to XC, it will cancel, and Z is equal to only R. So here Z is equal to only R. Okay, let us call it as Z at resonance as ZR, and we have to find what is at F1 and F2, what is the value of that Z value. So let us first find out what is the value of Z value at F1 and F2. After that we'll continue. At F1 and F2, at F1 and F2, current is given by Im by root. I already told here at resonance I max you are going to get, and similarly you are going to get P max also. And bandwidth we are going to calculate, at least power should be off. So this point you are going to get P max by 2, Pm by 2. Okay, P max by 2. At when power is maximum, we have resistance as R only. Now at half power frequency, what is the value of R? What is the value of Z? We have to find out now. So, and current at this point is given by Im by root 2. So that I explained in this here only why it is root 2. You have to take P max is I square into R, and I max square we can write as Im by root 2 whole square. So Im by root 2 is the current value at that point. Okay. So now current at resonance is I max, current at for frequency is Im by root. So now current is Im by root 2, and the impedance is equal to root 2 times the value of impedance at R. So let us take impedance at resonance is ZR is equal to only resistance. At F1 and F2, Z is equal to root 2 R. So why it is root 2 R? You can see right side definition. We know that Z is equal to, actually V is equal to what? I is equal to voltage divided by Z, and Z is equal to V by I. At F1 and F2 we have I is equal to Im by root. So Z is equal to V by I. Substitute at F1 and F2, I value is I by root 2. So this root 2 will go to numerator, and we'll get root 2 times V by I max. V by I max is nothing but, okay, it is voltage by maximum current. So here we call it as current. V by I is nothing but R. So when current is maximum, the impedance ZR is nothing but it purely behaves like a resistance R. So Z is equal to root 2 times R. That's why at resonance, remember this formula. This is not required to write in the exam. At F1 and F2, the impedance will be equal to root 2 times R, where R is at resonance circuit value will be equal to only purely resistance, that value. So at resonance here we have R at these 2 points, at F1 and F2, at this point and this point. Okay, your Z is equal to root 2 times R. In both the cases, left side F1 also, right side also, in these 2 points, mean the middle point Z is equal to R only. Here Z is equal to Z1 is equal to root 2 times R. Here also root 2 times R. So that is now in general r is equal to given by square root of magnitude is given by root of r square plus xl minus xc whole square. At f1 and f2 we know that z is equal to root 2 times r. Okay, at f1 and f2 z value is replaced by root 2 times r is equal to r square minus xl minus xc whole square. Now square both sides. Okay, now square both sides. Square both sides. So root 2 r whole square is equal to root 2 get cancelled. We will get to 2. Root 2 whole square is 2. R square is r square you have to write. And this if you square both side, this whole square will get cancelled. You are left with only r square plus xl minus xc whole square. Now we have 2r square here, right side 1r square. If you bring this r square left side, 2r square minus r square is r square. Here we left with xl minus xc whole square. So r square is equal to xl minus xc whole square. So therefore r is equal to, if you take a root of this xl minus xc plus or minus xl minus xc. So this is very important step for derivation of that f1 and f2. R value is given by root of xl minus xc. That is possible because z is equal to root 2 times r means zl is equal to root 2 times r means you should have this also r square only. This also r square mean this also you should get r square only. If you get this r square, then you will get r square plus r square is 2r square, and that is equal to root 2 times r. So we shown that at resonance at f1 and f2 xl minus xc r value is equal to plus or minus xl minus xc. So based on that we are going to derive now. Now consider at f1 this one left side, here we have omega L, no? We have omega L and omega C. This is omega L, this is over omega C. And omega means 2 pi f. It is directly proportional. For lower frequency, we have XLS. For higher frequencies, omega L is greater. Similarly, opposite for this, it is inversely proportional. For lower frequency, X is greater. And for higher frequencies, this is lesser. So for lower frequencies, XL, XC is greater than XL. For higher frequencies, XL is greater than XC. So let us consider at F1. Okay, at F1, XC is greater than XL. XC is greater than XL. Hence, equation 1 can be written as here plus or minus is there, no? So you can write R is equal to XC greater than, let us consider. Okay, consider XC greater here, XC minus XL. R is equal to XC minus XL. So R is equal to XC means 1 by omega 1C. XL means omega L into R. So XL is omega L. XC is 1 by omega C. And since we are talking about F1, so you have to write omega 1 at lower cutoff frequency, no? So instead of omega, you're writing omega 1 C and omega 1 L. So then next R is equal to take LCM. LCM omega 1 C. So you get 1 and this 2 you have to multiply. This and this. LCM is this. Cross multiply. 1 into 1 is 1. Omega 1 L into omega 1 C is omega 1 square into LC. And after that cross multiply again these two. Cross multiply. You are going to get omega 1 RC is equal to 1 minus omega 1 square LC, and bring this one here. This one you bring here, omega 1 square LC. Yeah, I'm bringing this one to left side. So this minus becomes positive. Here already plus is there, plus omega 1 RC, and this one also bring left side. You're going to get same answer. Okay. After that, this is in the form of quadratic equation ax square plus bx plus c. So you can divide throughout by LC, or without that also you can do. Without this also you can consider a as it is in the form of ax square bx plus c. No, this is x value is omega 1. So a value is LC. B value is RC, C value is minus 1. You can consider, and root of the quadratic equation is given by minus B, okay, minus B plus or minus root of B square minus 4AC, B square minus 4AC over 2A. Root of quadratic equation is given by minus B plus or minus B square minus 4AC by 2A. So B value is minus B value is RC plus or minus B square, R square into C square minus 4AC. 4 minus 4A is LC and C is minus 1. So minus into minus it becomes plus. And if you simplify this, you are going to get, okay, here you can see this is a quadratic equation A square plus BX plus C. Then X is given by minus B plus or minus root of B square minus 4AC over 2A. You can divide throughout by LC and you can do this, or you can with this one only you can do this. This is also correct. Dividing throughout with LC, this will get cancelled, and here C will get cancelled. We left with L here 1 by LC. So you can do either this or this. You can continue. You're going to get solution as omega 1 is equal to, here I can see this answer. Okay, this answer you can see down here. Omega 1 is equal to, okay, this is RC, no, CC will get cancelled. The C will get cancelled. R by this R by 2L plus or minus, okay, R by 2L plus or minus root of R square by 2L whole square plus 4C you are going to get. And solution for this equation is given by this 2, no, this 2 is here actually. You can write from this, I think not this one, this value R by 2L, R by 2L plus or minus R by 2L whole square plus 1 by LC. So this is the value of omega 1, unit is radians per second. In terms of frequency, you can write F1 is equal to, omega 1 is nothing but 2 pi 1. Omega 1 is nothing but 2 pi F1. So F1 is equal to R by rho divided by 2 pi. Okay, 2 pi you have to write here. And here also you have to divide by 2 pi. F1 is equal to 1 by 2 pi of this whole thing. That is F1, or you can keep in radians per second, or this is in hertz. This is in hertz, this is radians per second. And this is the expression for F1. Expression for F1 or omega 1 is R by 2L plus minus R by 2L plus root of R by 2L whole square plus 1 by LC. So this is, we got a expression F is equal to F1. We consider X is greater than XL at this point. At this point, X is greater than XL. Similarly, you have to derive expression for F2 or omega 2 by considering at this another of frequency at F2. Now instead of X is greater than XL, now we have to consider XL is greater than XC. XL is greater than XC. So same derivation one more time you have to do at F2. At F2, XL is greater than XC. So here you can write, here R is equal to, we started with R is equal to XL difference XC, no? So now you have to consider XL is greater than XC. So XL minus XC you have to write. R is equal to XL minus XC you have to write. For lower frequency, you have to write XC greater than XL, XC minus XL you have to write. Now we are writing XL minus XC. So omega, now for frequency F2, omega, no, omega is 2 pi F. So instead of F, we have to write F2 and it is omega 2L minus 1 omega 2C. So R is equal to, okay, R is equal to, take LCM, omega 2C, cross multiply, okay, cross multiply, it is omega 2 square LC minus 1 And again, you cross multiply this and this and this and this. It is omega 2 RC is equal to omega 2 square LC minus 1. Next to omega 2 LC square. This term you bring it to right side. Omega 2 square minus, if you bring it to right side, it becomes minus omega 2 RC. This minus 1 I keep as it is. Then divide throughout by LC. Divide throughout by LC. Omega square. This C will get cancelled. We left with R by L and 1 by LC. Again, this is a quadratic equation. Okay, it's a quadratic equation. A x square minus bx plus c. A value is 1. B value is minus R by L. C value is 1 by minus 1 by LC. So minus B plus or minus B square minus 4AC over 2A over 2A. So minus into minus is plus by this 2 is there, no? This 2 you bring it to here. Minus R by 2L plus or minus. Okay, this 2 if you bring it to the numerator, this is outside denominator only 2 is there. If you bring it inside this root, it becomes 4. Okay, it becomes 4 and R by 2L whole square. So it is nothing but R square by 4L square only. You will get R square and L square. Here you will get R square and L square. If you bring this 2 inside this root, it becomes 4. 4 can be written as 2 square. So R by 2L whole square. And again, this 4, if you bring it inside the root, it becomes 4. So 4 will get cancelled. You left with only minus into minus, it is plus 1 by LC. So expression for omega 2 is given by R by 2L plus root of, this is plus and minus is there, frequencies cannot be negative, so you have to consider plus only. So plus root of R by 2L whole square plus 1 by LC. So this derivation is important. Again, this is in terms of radians per second. In terms of frequency, F2 is equal to omega 2 is 2 pi F2. So F2 is given by this, throughout you have to divide by 2 pi. Throughout you have to divide by 2 pi, but unit you have to change it to hertz. Okay. So note, okay, you have to note, consider it a note. But the derivation means you have to write this much only. This is for asked for 10 marks. F1, F2 means you have to write like this. If they ask omega and omega 2, you have to write like this. This is sufficient. You can stop here only. You can stop here only. So sometimes we have to consider equivalent. You can reduce that formula to simpler. This one no need to write. But in the problems, we can consider this. Suppose in the given derivation, suppose R by 2L whole square is greater than, very much less than LC. This part is very much less. This square R by 2L square is very, very less compared to the 1 by LC. Then we can ignore this R by 2L whole square. We can consider it as, we can ignore this part. We can consider 1 by LC. Okay. That is the case if the quality factor is greater than 5. If the quality factor Q value is greater than 5, then R by 2L square will be very, very less compared to the 1 by LC. Okay. So then we can ignore that in the equation. Can ignore this part. We can write only, we can remove it and you can write only root by LC. Root by LC is nothing but omega R. Root of LC is nothing but omega R. Resonance frequency is given by 1 by root LC. Okay. So this is omega R. So it is omega R minus R by 2L, minus R by 2L. So from center frequency omega R, you have to subtract R by 2L value. That is possible only if Q is greater than 5. That means 1 by LC value is very, very high compared to R by L, 2 by L, R by 2L whole square value. Similarly, omega 1 is this much. So if you divide throughout by 2, multiply it, 2 pi F, no, 2 pi F1 is equal to 2 pi FR. This one, no, now divide throughout by 2 pi, we'll get 2. F1 is equal to 2 pi will get cancelled. Here R by 2L divided by 2 pi, it becomes R by 4 pi L, R by 4 pi L. This formula You can consider only if the specify q is greater than 5. Similarly, for omega 2 also, if you consider q is this part is very less compared to this, we can ignore this. This can be written as omega r. So here omega r plus r by 2l. So f2 is given by fr plus r by 4 pi l. But in the exam, if they ask expression for cutoff frequency f1 and f2, f1 and f2 means you have to write expression for omega 1 and omega 2, and f1 is this and f2 is this, and bandwidth is f2 minus f1. It's a very, very important derivation. Okay, thank you.